A never-before-seen tank component has appeared at SpaceX's Starbase facility, and seasoned engineers are struggling to identify what they're looking at. This hybrid structure combines elements from both booster landing tanks and ship header tanks, with additional welded components that don't match any known Starship configuration. The real mystery? Instead of heading to Mega Bay 2, where all Starship components are assembled, this tank went directly to Mega Bay 1, exclusively reserved for super heavy booster work. This placement breaks every established protocol at Starbase. What could justify moving ship hardware into booster territory? Let's dive right in. This mystery tank reveals components that engineering logic says shouldn't exist together. Visual analysis shows booster landing tank elements fused with ship header tank features, plus an unidentified component welded to the side that matches no existing SpaceX blueprints. But the real evidence lies in facility protocols. Mega Bay 2 exclusively handles Starship upper stage assembly, thermal protection, payload integration, structural work. Mega Bay 1 is reserved solely for super heavy booster operations, engine installations, structural integration, variant development. In 3 years of Starbase operations, this boundary has never been crossed. This tank broke that rule, which means SpaceX engineers are working on something that doesn't fit their established categories. The timing of SpaceX's belly-to-belly docking renders isn't coincidental. These images show 2 Starships connecting in orbit using 4 precise docking points, 2 forward for alignment stability, 2 aft for fuel transfer operations. This mystery tank's structural design could form the reinforced leading edge, where forward docking points require maximum strength. The positioning makes sense for orbital refueling operations, but building this component in a booster facility suggests something bigger is happening. The answer becomes clear when we examine what SpaceX has been quietly developing behind the scenes. Starship Block 3 represents the most significant design overhaul since the program began. SpaceX is implementing dual quick disconnects for liquid oxygen and methane, completely eliminating the problematic Raptor engine connections that have caused weeks of refurbishment delays. The structural changes go deeper. Heat shielding disappears, replaced by metallic thermal tiles on the aft plate. The grid fin system gets redesigned from 4 standard fins to 3 fins that are 50% larger, enabling steeper descent angles and superior re-entry stability. Most significantly, the new integrated hot stage forward dome uses a truss-style hot staging ring. This isn't an upgrade, it's architectural revolution that changes how booster and ship separate entirely. These modifications directly connect to our mystery tank, because Block 3 also transitions from Raptor 2 to Raptor 3 engines. Raptor 3 engines deliver a 40-ton payload capacity increase, bringing total reusable capacity beyond 100 tons. To understand this scale, current Falcon Heavy delivers 64 tons to low Earth orbit in expendable mode. Block 3 Starship exceeds this while remaining completely reusable. Ship 39, currently under construction in the Star Factory, already shows thermal protection tile installation, confirming Block 3 has moved from concept to active manufacturing. But this timeline reveals why our mystery tank creates such confusion among SpaceX veterans. The component's hybrid design suggests it serves multiple functions across different vehicle configurations, which explains why traditional facility assignments no longer apply. Elon Musk's cryptic "You'll thank me later" post connects directly to SpaceX's expansion strategy. The company is acquiring a new transport vessel, potentially the Marmac 308 barge, measuring 91.4 meters by 30.5 meters. This vessel can transport multiple Starships horizontally or accommodate up to 12 vehicles in vertical configuration. The FAA's environmental impact statement confirms the operational approach. Starship Super Heavy would employ similar recovery operations as Falcon, but requires newer drone ships for horizontal transport to Port Canaveral. This transport capability enables SpaceX's most ambitious plan yet: 44 Starship launches annually from Kennedy Space Center's Launch Complex, 39A. 44 launches per year equals nearly 1 Starship mission per week. The infrastructure requirements are staggering. 44 booster recoveries, 44 Starship landings, all requiring new ground systems at America's premier spaceport. However, this expansion creates unprecedented challenges. Each Starship operation requires airspace closures lasting 40 minutes to 2 hours, potentially affecting 400 to 600 commercial flights during peak travel periods. Major Florida airports, Tampa, Orlando, Miami, Fort Lauderdale, could experience regular ground stops. The hazard zones for Starship operations are exponentially larger than Falcon 9 requirements. While hundreds of Falcon launches operate with minimal airspace disruption, Starship demands massive coordination with commercial aviation systems. This scale of operations explains why SpaceX needs revolutionary hardware, like our Mystery Tank. Traditional approaches can't support this launch cadence. Recent events highlight the gap between SpaceX and traditional aerospace. Northrop Grumman's Cygnus XL spacecraft experienced main engine shutdowns during orbital maneuvering, preventing its planned approach to the International Space Station despite launching successfully on a SpaceX Falcon 9. While Northrop struggles to deliver 11,000 pounds of cargo to low Earth orbit, SpaceX prepares to transport 100-ton payloads to lunar orbit. The technical complexity difference is generational, not incremental. This performance gap intensifies as international competition heats up, particularly China's aggressive lunar timeline. China's lunar ambitions create urgency that influences every SpaceX design decision. The Mystery Tank could represent lunar-specific hardware designed for human landing system operations, making it moon-bound equipment currently under development at Starbase. Orbital refueling technology changes the entire strategic equation. Instead of launching with maximum fuel loads, Starships can refuel in orbit using dedicated tanker variants, multiplying deep space payload capacity exponentially. The belly-to-belly docking system serves this larger vision. Not just lunar missions, but Mars colonization, asteroid resource extraction, and permanent space infrastructure development. SpaceX isn't just manufacturing rockets. They're constructing the industrial foundation for space-based civilization. Launch towers, landing platforms, fuel production facilities, payload processing centers represent a comprehensive space infrastructure system. Our Mystery Tank symbolizes this transformation. Traditional aerospace categorizes components as either booster hardware or spacecraft systems. SpaceX is creating hybrid technologies that serve multiple vehicle configurations across different mission profiles. This approach enables rapid iteration and cost reduction while supporting unprecedented launch frequencies. The secrecy surrounding this component suggests accelerated development timelines. If lunar missions are approaching faster than public announcements indicate, every piece of hardware becomes critical path for mission success. Seasoned SpaceX engineers expressing confusion indicates this tank represents significant departure from established design philosophy. That level of innovation only occurs when major mission requirements demand revolutionary solutions. The facility protocol break, hybrid component design, and development timing all point toward the same conclusion. SpaceX is preparing for operations that current public timelines don't reflect. What's your theory about this Mystery Tank's true purpose? The SpaceX community has collectively solved engineering puzzles before? Drop your analysis in the comments and let's figure this out together. This is exactly why those engineers went speechless. That Mystery Tank isn't just hardware. It's proof that SpaceX is building multi-purpose components that work across different vehicle configurations. The protocol break at Starbase signals a fundamental shift from traditional aerospace design to modular space infrastructure. What this means is revolutionary. We're witnessing the birth of standardized space technology that can adapt to any mission profile, from lunar operations to Mars colonization. This development positions America decisively ahead in the new space race. While competitors struggle with single-mission vehicles, SpaceX is creating reusable, adaptable systems that make space access routine rather than exceptional. Block 3, Starship with 100-plus ton capacity, doesn't just reach the moon, it makes lunar industrialization economically viable. And this is just the beginning. Ship 39's construction timeline suggests Block 3 operations could start within months, not years. The 44 launch Florida expansion means we'll see more Starship flights in 2026 than the entire Space Shuttle program completed in 3 decades. How do you think this modular approach will change Mars mission planning? Will standardized components accelerate deep space exploration or create new technical challenges? Drop your predictions below. The space community's collective insight often predicts SpaceX's next moves. This is Space Hub, and we dive deep into space breakthroughs that reshape human civilization. If you want more analysis that connects the technical dots to the bigger picture, you know what to do. We're not just watching rocket development, we're witnessing the infrastructure decisions that will determine humanity's path to becoming a spacefaring species. SpaceX has just revealed calculations that stun NASA officials. They can transport 100,000 metric tons to the moon using 1,000 Starship launches, the exact same number already planned for Mars missions. While NASA designs small lunar outposts for 4 astronauts, SpaceX is planning something unprecedented, a permanent lunar city. The numbers are real. Each Starship can carry 100 tons to the moon. The technology exists, but the implications are staggering. We're looking at humanity's first extraterrestrial civilization, not just research stations. Let's dive right in. The cost difference reveals why SpaceX thinks so differently. Traditional space missions cost $10,000 per kilogram to launch materials to the moon. Starship drops this to under $100 per kilogram, a 99% reduction that makes lunar construction economically realistic for the first time. This dramatic cost shift explains everything. NASA carefully budgets for small, temporary missions because every kilogram costs a fortune. SpaceX can think in terms of entire cities because their transportation costs make large-scale construction feasible. The economic barrier that limited space exploration for decades just disappeared. NASA identified 13 potential landing zones near the lunar South Pole, but SpaceX zeroed in on the Shackleton-de Gerlache Ridge for compelling reasons. This location offers 3 critical advantages: permanent shadow regions containing water ice, nearly constant sunlight for power generation, and direct line-of-sight communication with Earth. Water ice solves multiple problems simultaneously. It provides drinking water, breathable oxygen through electrolysis, and hydrogen fuel for rockets. Constant sunlight eliminates the power storage challenges that plague other lunar locations. Earth visibility ensures reliable communication without satellite relays. It's prime real estate, lunar style. Here's where the plan becomes genuinely revolutionary. Every kilogram produced on the moon saves 61 million joules compared to shipping from Earth. Enough energy to power an average home for 17 hours. This energy savings makes local production not just practical, but essential. Lunar regolith contains everything needed for construction: oxygen, iron, titanium, silicon, magnesium, and aluminum. These elements can be processed into metals, ceramics, glass, and structural materials using proven technologies. NASA's hydrofluoric acid leach system already demonstrates how to extract usable materials from regolith. The Redwire Regolith Print project proved 3D printing works with lunar materials in space conditions. The manufacturing starts immediately. Automated systems arrive on early Starship flights and begin producing basic materials while human crews are still on Earth. By the time astronauts arrive, construction materials are ready and waiting. The building sequence follows a logical progression. First priority: landing pads made from melted regolith using concentrated sunlight through Fresnel lenses. This isn't theoretical. The European Space Agency's PAVER project validated the technique using simulated lunar conditions. Landing pads aren't luxury items. They're survival necessities. Lunar dust particles are microscopic glass shards that damage equipment on contact. Apollo 17 crews faced equipment failures from dust coating. Soviet Luna 2 rover died from dust-induced overheating. Each unprotected landing blasts tons of abrasive particles across the construction site. Paved surfaces prevent this destruction before it begins. Roads come next, connecting landing areas to construction sites. These aren't for convenience. They're essential infrastructure. Smooth, dust-free pathways protect rovers, equipment, and eventually people moving between facilities. Each road extends the operational radius and enables larger construction projects. NASA's planned habitat demonstrates sophisticated engineering, a 7.8-meter tall, 6.5-meter diameter inflatable structure that fits in a 5-meter rocket fairing. The design includes a metallic core, rigid lower section for equipment access, and multi-layer protection against micrometeorites and temperature extremes. But SpaceX's vision scales beyond single habitats. Multiple structures create neighborhoods connected by pressurized walkways. Specialized buildings serve different functions: workshops for manufacturing and repair, laboratories for research, recreational facilities for psychological health. The result resembles urban planning adapted for the most hostile environment humans have ever tried to inhabit permanently. Solar power works perfectly during lunar day, but lunar night lasts 14 Earth days. Battery systems capable of powering a city for 2 weeks would consume dozens of Starship launches just for energy storage. The solution? Nuclear reactors. NASA's acting administrator Sean Duffy targets operational lunar reactors by 2030. These aren't experimental concepts, they're proven technology adapted for lunar conditions. Nuclear power provides continuous, high-output energy regardless of solar conditions. Unlike Earth applications, lunar reactors operate in vacuum with no atmospheric contamination concerns. Nuclear power enables industrial operations that transform the lunar economy. Instead of rationing energy for basic survival, abundant power supports manufacturing, communications, life support, and expansion activities simultaneously. The moon offers unique manufacturing advantages impossible on Earth. Near-vacuum conditions enable ultra-pure metal production without atmospheric contamination. Perfect crystals grow in low-gravity environments. Pharmaceutical manufacturing benefits from sterile conditions and precise temperature control. Extreme dryness creates electrostatic effects useful for material handling and sorting. The stable lunar surface provides vibration-free platforms for precision manufacturing. Variable gravity between surface operations and orbital facilities enables specialized production techniques. These aren't just technical curiosities, they represent export opportunities. Lunar manufactured products command premium prices on Earth due to their unique